You're watching TelecomTV's exclusive video coverage of the SDN and OpenFlow World Congress event from Dusseldorf. And I'm joined now by Peter Marek of Advantech and Mark Gwinther of Netronome. Peter, Advantech has just announced a new product for 100 gig flow processing. Why is this significant?
The networking industry that gathered here at SDN World Congress is just about to find out that white box servers won't really work well to handle 100 gig data flows. What that means is that we all know about SDN and NFV transforming the networks. We all are aware that internet traffic is just exploding. And at the end of the day, all of us smartphone, phablets, tablets, or whatever users, we're just pushing more and more distinct flows onto the networks. And that all leads to much more larger complexities in the design of the networks that are supposed to carry these flows. And at the end of the day, it means standard gear doesn't really scale to those complexities.
And Mark, why is this solution important?
Well, if you look at what needs to happen at data rates of 10 gig, there's millions and millions of packets that need to be processed by boxes like a firewall or a gateway or a load balancer. And that problem becomes more extreme at 40 gig and 100 gig. So when you add virtualization on top of that, you have yet another layer of complexity. And even though you add CPU cores to the mix, you don't want those CPU cores spent shuffling data around. You really want those CPU cores spent running your application software.
The FWA 6522C is your new platform for high bandwidth flow processing. Tell me more about this platform that you're calling an ultra high-end network appliance.
What this appliance does is it integrates 4 high-performance Xeons with up to 400 gigabits of modular and scalable I/O. And unlike the standard white box servers that we just talked about, we put an intelligent FlowNIC in between the I/O and those Xeon processors to provide optimum packet delivery from I/O into the Xeons. And that way, we can make most out of the integrated Xeon processors without breaking standard software programming environments.
Mark, why is it that white box server platforms are going to struggle to run data plane intensive applications dealing with 100 million flows?
I can think of 3 reasons why white boxes aren't going to cut it here. First of all, there's no one-to-one mapping between the input ports and the CPU. So you have to send all the input to one CPU, and then that tries to decide where the packets need to go. So you have cache misses, and you have QPI latencies. Secondly, if you have any kind of virtualization going on, you have to run virtual switching in your box as well. And there's a lot of effort spent to accelerate virtual switching, but even if you move it into user space, you're still spending CPU cycles running that virtual switching, which brings down your performance. And then third, you have to look at the overall system performance and how does it scale across multiple cores and multiple sockets. And you add those things together, and this is why white boxes really aren't going to perform. So the idea here is to add a layer of intelligence in front of those Xeon processors so you can filter the packets, classify them, send them exactly where they need to go, to the right socket, the right core, and the right thread and virtual machine on that core.
And Peter, what about the programming model? How difficult is it going to be for developers to bring these 2 different processing technologies together?
Well, traditionally there had been hybrid processing approaches out there in the industry that had all these complexities. So the real magic about our ultra high-end appliance is that it doesn't break existing programming models. So from a data plane perspective, Netronome's FlowNIC presents itself like a regular NIC to each socket. So that's 4 NICs in one chip. And by doing that, the application programmers can use the same software programming model that they use on platforms that don't have the FlowNIC. Either if that's Linux kernel drivers or it's userland drivers like DPDK, it is consistent and they don't have to rewrite their applications to make use of this exciting technology.
The fine-grained nature of the FlowNIC and its ability to process packets make it a good candidate for a lot of different applications. Right now, we're seeing most traction in enterprise security with this box, so that's things like firewalls, next generation IPS, IDS, gateways, analytic devices, lawful intercept, things like that. But if you add virtualization on top, this is also an excellent NFV platform for things like virtual CPE or evolved packet core or multi-tenant kinds of applications.
Peter, why has Advantech partnered with Netronome?
So Advantech is a provider of hardware platforms, and we have a very broad range of Intel-based networking platforms. And our mission in the industry is, of course, to solve our customer headaches. And as this industry transforms, we said, well, an Intel-only solution won't do it. So we were looking for a partner that could help and give us some additional technology, and we're glad we found Netronome that has a perfect solution that fits also our product planning.
And Mark, what's the benefit to Netronome of partnering with Advantech?
Yeah, we're glad they found us too. Netronome has been around for a while now, but we are on our second generation of silicon, which was perfect for the kind of box that Advantech wanted to build here, because we can front end all those x86 cores with intelligent packet processing. And this is exactly the kind of box we had in mind when we built the high capacity 4 PCI capabilities into our chip.
So have you had good response so far from the SDN World Congress?
Well, yes, we really enjoy being here at this event. It has been great for us. It is a good gathering, not only of potential customers and users of our gear, but also of all of the ecosystem partners, so it spurs up more collaboration in the ecosystem, which is actually needed, and ultimately this will drive more innovation in this networking industry.
Peter, Mark, thank you very much.